does not contain an equals or an inequality sign. Expression that contains a radical. Okay? Now, a radical function now. Okay, now what about a function? A radical function is defined as it contains a radical expression okay, with the independent variable. And I want to see if you guys remember what that is here in a second. Independent variable under the radical. Or in the radicand, I'm sorry. Well, this means the same thing. In the radicand. Now guys, if you don't know what this means, when I say in the radicand, it means under the radical sign. So it means, guys, now who remembers what the independent variable is? X or Y? Which one is the independent? X or Y? X, exactly. Let's put that right by the independent variable. You need to know that X is your independent variable. So that means that our variable X will be underneath the radical. So if this is here's an example. Y equals the square root of X. Y equals the square root of X, and then outside plus 1. Or Y equals the square root of X minus 3. Those are all radical functions because where is the variable? Where is the independent variable, guys? Where is the independent variable X located? Underneath the radicand, which means in the radical or underneath the radical. Okay? Okay, these are all radicals. You don't need to write these down, but this is a radical. That's a radical. Okay, those all are radicals because they have this is called the square root, this is called a cube root, okay? But they're all radicals. Okay, so when you hear me say a radical, it means it has one of these signs or symbols, okay? So we understand that a radical expression is an expression that contains a radical, okay? All right, a radical function contains a radical expression and also has an independent variable underneath the radical. Underneath the radical or in the radicand is what it's called. All right, the last thing is what we're going to be dealing with is in this section, guys, is no cube root functions, nothing other than just square root functions. So let's make sure we talk about that. A square root function is really a radical function. Okay, a square root function. Okay. So if the radical is this, then it is a square root function. So everything, well, first of all, are these all square root functions then? They are, aren't they? So all of these, right here, are square root functions. And that's what we're dealing with today. You're going to see me doing a problem like this. You're going to see me having to do a problem like this. You're going to see me doing a problem like this today. And we're going to show you how to do those. Okay? And how to graph those. Okay? So we have a radical expression, radical function, and then underneath the radical function, this is a square root function is a type of radical function. So it's just a more specific type of radical function. Okay? All right, how do we graph these? How do we graph these radical functions or square root functions? Let's put down the steps for this. The steps in graphing square root functions. We're going to be even more specific. We're going to say square root functions instead of radical functions. Okay? Here we go. Step 1, okay, is to first of all make a table. Which every time we graph, what do we always do? Make a table. Now here's what changes. Here's what I want you to make sure you understand, that whenever you're graphing a square root function, what number can we not take the square root of? Negative numbers. So remember how we used to use our convenient domain? What was our convenient domain in the past? -2, -1, 0, 1, and 2, right? Well, can we do that though with this one? We can't, can we? we have to make sure that we have a number under the radical that's at least 0 or greater. So when you're making your table, you need to make sure you understand that. You need to make sure that you're careful with your domain. Now, I'm not going to put down that you always have to use positive numbers. I'm going to show you that sometimes you don't have to use positive numbers for your independent variable. But be very, very cautious of that, okay? All right, make a table. Step 2 is to, obviously, well, let me just put down this, I guess. Cannot have, this is just a reminder, I guess, cannot have a negative number under the radical. That's what I just want to make sure I point out. It's not really a step, it's just a thing I want you to pay attention to. Okay, cannot have a negative number under the radical, or in the radicand. Okay, I just want to make sure you understand that. Not always does that mean that you have to put in a non-negative number for the domain, but that means that whatever's underneath the radical cannot be negative. Okay, you often have to graph. You need to make sure that once you make your table, you figure out what your domain range is, you're going to graph a smooth curve. Okay, a smooth curve through the points. Okay, and then obviously the last thing is to compare. Now, you heard me say compare, so I haven't talked about this yet. You're going to compare your graph to what we call the parent square root function, which I have not talked about yet in the notes yet, so I need to go back here and talk about that. Compare your graph to the graph of y equals the square root of x. What do you think y equals the square root of x is called, guys? If you remember our parent functions, okay? So go back to your vocabulary here, and I want you to add this to your vocabulary, please. It's called the parent. You've heard that term before. Parent, bless you, square root function. That's the one thing we need to add to our notes and add to our vocabulary. It's called the parent square root function. The parent square root function is the most basic square root function there is. Most basic square root function. Okay? And that is, I already wrote it down, y equals the square root of x. That is the most basic square root function there is. There's nothing more easier to graph or easier to, I guess, do a table for than the y equals the square root of x. Okay? Let's make a table for that, and so you can understand what I mean by the domain. Okay, let's say I wanted to graph this function, this parent square root function. What would I do for a table? Guys, what number would I put in here for my first domain? 0, right. Because what is the square root of 0? 0. So is that my first non-negative number I can use? Yeah, because what if I try to put -2 in there? What would it say? It'd say error, wouldn't it? Because you don't have a real number answer for your range. You get an imaginary number, which we deal with in Algebra 2, but we're not dealing with that yet here. We're just dealing with real numbers. Okay? What's the next number that we might want to put in here? 4. Okay? Now, someone said, could we use 1? Could we use 1? What is this? Actually, no, 1 would be the nice one, wouldn't it? What is the square root of 1? 1. Now, what's the next perfect square? Do you see what I'm looking for? I'm looking for perfect squares. What's the next perfect square after 1? 4. What's the square root of 4? 2. Look how easy these are to graph, guys. What's the next perfect square after 4?
8.
Nope. 9, right? Let's put 9 down. What's the square root of 9? 3. And what's our last one going to be? 16. What's the square root of 16? 4. Now look how easy those are going to be to graph. So if I graph that, watch. This is the graph of the most basic square root function there is. It's called the parent square root function. So now I'm going to go, I start at the origin, and I go over 0 and up 0, which means obviously I stay right at the origin. Here's my first point of y equals, again, I'm graphing y equals the square root of x.
Are we doing this?
You can, yes, I want you to do that too, yes. Over 1, up 1, so you know what it looks like. There's the next point on your curve. And then over 4, up 2. There's your next point. And then over 9, up 3. And then over 16, up 4. And there's your other point. Now, did I have to use all perfect squares? No, I didn't have to, but those are the easiest ones to plug in for square roots. Does everyone understand that? By using perfect squares, when I take the square root of perfect squares, it's really easy to get the range values. So here's my curve. Okay? Now guys, the one thing I did not tell us to do here is I didn't tell you to go ahead and write what the domain and range was. So guys, let's go back to our table. What is our domain? I need to write my domain and range with inequality signs. What did you notice? What number did I start my domain with? 0 and what? Number is what? Less or greater? So how would I write 0 and greater as an inequality? Greater than or what? Equal to what number? 0. How would I write my range? Would it be this? Okay? You guys need to make sure that you write your domain and range every time you go ahead and do a square root function. You need to identify the domain and range. So let's put that on our table to make sure we don't forget that. Actually, let's make that kind of step 2, or add that to make a table. And then identify domain and range. And don't write it, don't list them. You don't list them, you write them as an inequality sign to say, because guys, could I, and I said this earlier, could I have used 0, 1, 2, 3, 4?
Yes.
I could have, couldn't I? But you know what's going to happen? You're going to end up with decimal answers, approximate it. It still works. Because watch. What if I would have used 2? Guys, tell me what the square root of 2 is in your calculators real quick. I believe it's like 1.4 or 1.3. What is it? 1.4. Okay, guys, can I graph 1.4? Watch. Over 2, right? Over 2 up 1.4. Is that right here?
Yeah.
That's still on my curve? So could I have used 3? Could I use 5? Could I? Notice that I picked. What did I end up picking though? Numbers that were what? Perfect squares. Did I have to use perfect squares? No. But what did I have to start with? I had to start with 0 though, because I couldn't take the square root of a negative number. Okay, does that make sense? Okay, good. All right. Now, what's the purpose of all this? Well, you have to be able to know that if I asked you to graph another function, another square root function, can you compare it with this graph? Vertical stretch, vertical shrink, reflected over the x-axis, just like we did with parabolas, isn't it? Vertical stretch, vertical shrink, reflected over the x-axis, same exact comparison. So there's nothing new with that. Now we need to learn how to graph these, which means we're still going to follow these same steps, no matter what square root function I give you. Okay, let's go ahead and graph those. And I'm going to keep this down here so you can see it, the square root function, so we can compare it to that graph. And I'm going to keep that one right up there on the board. And then whatever one I do, we're going to do it in a different color to show you how they look different.